Ordinary matter consists of electrons, protons, and neutrons. So far, this information was enough to understand what our universe is made up of. But things are not always this straightforward. Hundreds of other elementary particles have been discovered during high energy collision between particles. It has become clear that some of these newly discovered particles are the fundamental or elementary particles, and some of the newly discovered particles are combinations of further even smaller particles called quarks. So let's have a look at this new standard model of particle physics in detail, which talks about what electron, proton, and neutrons are made up of. We all know that there are four basic kind of forces. Strong nuclear force that acts within the nucleus, weak nuclear force that accounts for the radioactive decay, then comes the electromagnetic force, we already know about it, and last one is the gravitational force. Alright, so the standard model of particle physics talks about two things. First, what is all the matter made up of? Secondly, how that matter interacts with each other when these forces are present. Okay, so the standard model of particle physics says that the forces between particles are caused by other particles. For example, if you are bringing two magnets close together, you don't have to touch the magnet to feel the force, right? At a distance also you can feel that magnet are either attracted or they are repelled. So particle physics talks that actually very fine subatomic particles are being exchanged when you bring two magnets together. So therefore it says that forces between particles are caused by other particles. Alright. Secondly, it talks about that all the matter is made up of 12 fundamental particles. What are these 12 fundamental particles? We will look into detail. The standard model of particle physics mainly talks about two types of particles, fermions and bosons. In some of the books, bosons are also known as Gauss bosons. But for simplicity, let's stick to bosons. Okay? Fermions are the particles, the fundamental particles that make up all the matter. Okay? Bosons are the particles that cause the various interactions between the particles. Remember the example of magnets. So the particles that cause the magnets to attract or repel are bosons, and the particles that magnets are made up of are called fermions. Now we will have a look at fermions and bosons in detail. Before understanding fermions, I want you all to understand couple of terms that we are going to use. The first one is fundamental particle. They are also known as elementary particles. That means they cannot be broken down into further smaller particles. The smallest particle which a matter can consist of is the elementary or fundamental particle. It cannot be further divided. Okay. Second thing is antimatter. If you remember, while we were learning about Big Bang theory, we learned that all the matter had antimatter. Okay, and when matter and antimatter, they combine, a huge amount of energy is created and they annihilate. Okay, but during Big Bang theory, the Big Bang theory says that if there was 100 antimatter, for some reason there was 101 matter. So therefore, when they annihilated, energy was released, but one matter was left. So whatever we see around us, everything is made up of matter. Okay, but in the standard model of particle physics, we will talk about a particle, for example electron, and we will also talk about its antiparticle called positron. Okay, so all the elementary particles, they have their antimatter. Okay. Fermions. We have seen that matter is made up of 12 elementary or fundamental particles and their antimatter. Okay. These elementary particles are called fermions, which are defined by their quantum numbers. Now, what is this quantum number. If I ask you, which school do you go to? You will say, I'll go to XYZ school. Where is it? Which area? You will say Western Sydney, for example. I'll say Western Sydney where? You will say Liverpool. Which street? Some name of some street. What number? Then you will tell me the number. So in order to give an address, you have to give me so many details so that I can actually pinpoint, say, yes, I know that place. Similarly, quantum numbers. A particle has many different categories of quantum number and it has certain values which define that particle. And all the particles have different values of quantum numbers. Okay, so do not think too much about quantum number. Think of it as address. Every particle has to have certain things to make it like, okay, these are the characteristics of that particle. Those characteristics are given by those quantum numbers. All right. Fermions are 12 because we have seen that there are 12 fundamental particles. Fermions are divided into two categories: leptons, quarks. 6 leptons, 6 quarks. 3 will be matter, 3 will be antimatter. In quarks, 3 will be matter and 3 will be antimatter. Okay, we are going to have a look at leptons and quarks in much detail. But before this, because remember the standard particle model talks about fermions and bosons. So first let's have a look at bosons. Let's have a look at bosons. Okay, we have seen the 4 types of forces: strong nuclear, weak nuclear, electromagnetic and gravitational. Okay, and bosons are the particles. The standard model of physics says that bosons are the particles which cause these forces to act. For example, as I told you about the magnets, if the magnets, we don't have to put them physically together to understand if they're attracting or repelling. At a distance also there is an exchange of particles going on which causes the attraction or repulsion force. Okay, so out of these 4 forces, except for gravitation, the other 3 forces, that are strong nuclear, weak nuclear and electromagnetic, it has been proved that these forces happen due to the exchange of particles known as bosons. Now each of the force has its own boson. They have a different name. For example, when 2 electrons, okay, they are together, they will repel because they are of the same charge. So the particle that makes it happen is known as a photon, which is a type of boson. Now if we talk about strong nuclear force, which happens within a nucleus, it is happening because of the exchange of some bosons. Those particles are called gluons. Though it has not been proved for the gravitational force that there is an exchange of bosons, but scientists have given it a theoretical name, that's graviton, but it has not been practically proved yet. Okay, out of the 4 forces, 3 forces, that are strong nuclear, weak nuclear and electromagnetic, arise through the exchange of particles called bosons. As I mentioned, some book name it as Gauss bosons. Bosons are also called force carrying, force mediating or exchange particles. Force mediating means force causing. Each force has its own boson. So strong nuclear force has gluon, weak nuclear force has W plus, W minus and Z. These are the names of their bosons. And electromagnetic boson is named as photon. And gravitational boson, that is a theoretical boson not proved yet, it is called graviton. In order to understand bosons using a normal everyday example, think of you and your friend on roller skaters, okay, and you both have a basketball, okay, and you are throwing the ball towards your friend and he is also throwing the ball towards you and you are catching the ball. So when you will throw the ball, eventually you will move back on your skates, okay. So it can be taken as why the forces are repelling, because you two are moving away from each other gradually, okay. This is one analogy. And if you say that you are standing close with your friend and you try to grab its ball, pull it towards you, and then give your ball to him and he pulls it towards it without throwing the ball. In that case, you two will come near to each other. You will not move away, you will move towards each other. Think of it like attraction. This is the analogy which can be used to understand how exchange of particles can cause attraction or repulsion.